Yeah, can you repeat
My
your
question was, if Gibbs free energy is constant for a reaction, then if you decrease it, won't the reaction be different? And
that is a wrong question, because you can't decrease Gibbs energy. Like a chemical reaction is happening, matlab there is there is Gibbs energy being decreased because of that process. That's the whole deal with Gibbs energy, right? Like the whole point with delta G is that there is change in enthalpy. So enthalpy related to the heats of formation, like the bond dissociation, all of that, and also taking into account the entropy change that's occurring, like as the molecules atoms are being rearranged. So all of that together combined represents Gibbs energy. A reaction can occur, it is possible only if there is a decrease in Gibbs energy. Otherwise, it's not possible. This is something that you have studied before. Yeah.
If Gibbs free energy increases, then the reaction can't take place.
No.
only if it's greater than 0, na? Then it can't take place.
Greater than 0 is positive, na?
Yeah, then the reaction can't take place.
Yeah. So Gibbs energy is decreased. Energy decreased during a process, matlab there should be a simultaneous increase in the energy in some form.
Sorry, Gibbs energy is decreased, matlab spontaneity is increased.
Increased nahi. Gibbs energy decreased matlab it's a spontaneous reaction.
Isn't like everything, I'm not saying not everything, but so if it decreases, it's if it increases, it's not spontaneous at all.
No, that process will not occur. So that overall Gibbs and reduction Gibbs energy needs to be converted to some other form of energy. Like if Gibbs energy is decreasing, something else should be increased corresponding to it, right? Like that's how energy works.
Why? If the reaction is spontaneous, then why should something else change?
Reaction is spontaneous, matlab Gibbs energy is decreasing. Energy can neither be created nor destroyed. If Gibbs energy is decreasing from some value to some other value, so delta G, let's say hypothetically, is like some minus 100 kilojoules.
Well,
listen, delta G is minus 100 kilojoules, matlab initially it was at some energy and then it reduced by 100 kilojoules. Isliye reduced, isliye minus, and the numerical value of how much it reduced by is 100. Okay. So where did this 100 kilojoules go? What happened to it?
It was transferred into some other form.
Yes. So in an electrochemical process, like when you are like in the context of an electrical cell, it is this Gibbs energy which is converted into the electrical work. So in other words, it's converted into electrical energy that we say as electrical work done by the cell, because the reaction is what is causing the electricity to happen, the electrons to move.
Like unrelated question, but what was S?
S was entropy. Entropy is
so degree of spontaneity is entropy or Gibbs free energy? Entropy.
Gibbs energy.
If Gibbs energy is like a degree of measuring how spontaneous the reaction is, how can we just say that when it's decreasing, yeah, okay, it's spontaneous? I mean, it's like
that has to, we need to like go back to thermodynamics. Like that relates to the second law of thermodynamics. Like that's what that whole deal was. Yeah, so that's a completely different concept. So yeah, that's what the whole second law of thermodynamics dealt with. Um, that dealt with, like, that's what introduced the concept of entropy. And now only by using enthalpy we can't say that, okay, like, there's exothermic as well as endothermic. So entropy also needs to be taken into consideration. So that's decided by the second law of thermodynamics. There's a whole thing about entropy is always increasing in the universe. Like, if anything is happening naturally, it's being pushed towards more disorderliness. That's why, if the change in entropy in the overall universe is enough to overcome the change in enthalpy, making delta G negative, then that process will occur. Otherwise, if overall delta G is positive, taking into consideration the change in enthalpy and change in entropy, then that process won't occur. Like, that's the short of it, thermodynamics. Now coming back to this, any chemical reaction, spontaneous, delta G is negative. Matlab, there is a decrease in the Gibbs energy. In the context of electrical cells, that Gibbs energy is being converted into electrical work. How much ever decrease is happening, all of that is getting converted into electrical work. Okay. Clarified now? Clear? Makes sense? Yeah. So putting it into numbers. Now, remember back in physics, what is electrical work numerically equal to? How do you measure the electrical work? Like, work done in carrying some amount of charge across a potential, like, kitna, how much is the work?
V into Q.
V into Q, right? The potential into charge. Now, which should be equal to our delta G. So, in the context of our electrical cell, so delta G will be equal to, or let's take this one by one. So delta G is related to that chemical equation. V, which is equal to the potential, what will that be equal to in our the cell system, electrical cell system?
EMF? No, E not cell.
E. Standard conditions may E not, otherwise, yeah, that's the E cell. EMF of the cell. What is the total number of, like, what is Q equal to, the charge that we are talking about?
Charge on the electron. Like
That's,
into
yeah,
N.
yeah. N into the charge on the electron. Since we are considering in terms of moles, like taking molar units of concentration, this will be equal to N into F. So 1 mole of electrons into the number of electrons being exchanged. So that gives us the total charge.
Why not NE?
Huh?
Why not NE?
No, we're just, what do you mean? What is, acha, N into E. So F is basically equal to E, which is charge on an electron, into Avogadro's number. Since we are not calculating based on individual, or, it just makes calculations easier because we tend to calculate it in terms of moles. We are not considering every single electron or a single atom or a single molecule. We usually tend to concentration we take molar concentration, right? That's why it just makes things easier. NF. Okay. Cool. So putting this into our original formula, Gibbs energy can be written as NFE. This would be the standardized. So this would be the relation at any temperature. Like, when you're calculating delta G at a specific temperature, you need to take the cell potential also at that particular temperature. Let's make it, like, even more clear. Just write this E as E cell. Yeah. So or delta Rg if you want to write it as the Gibbs energy of the reaction. Also, this would be minus because the overall, like the decrease in this is equal to the increase in this. So to make it numerically equal, you're changing the sign of one of them.
Can you repeat why it's negative?
Negative because again, like delta G is equal to the work done by the system, right? And if you're looking at W equal to VQ, this kind of like you look at it from the point of view of the electrons ka system. So again, like this is to make sure that the system that you're considering, your frame of reference, is the same.
Both are of electrons only, right?
No, so
Cells work is done.
no, delta G corresponds to the equation. So what is lost by this is being gained by this. So one of them will be negative. Yeah, so this is the basic premise of delta G, relation between delta G and this thing. Variations of this at 298 Kelvin, like STP conditions.
Miss,
Hmm?
Miss, I still don't understand the negative sign. Please.
It's like it's basically equalize, not equalize. What words would be? So what is lost as delta G is being gained as electrical work, NFE.
Yeah.
So if you want to equate it numerically, like basically your frame of reference needs to be the same. Thermodynamics, we were dealing with similar conditions, right? Like work done on the system versus work done by the system.
Yeah.
So in that context, like here, W, like tell me what does W equal to VQ stand for in terms of like what exactly are we applying? Is this like work done on the electrons or like on the charge or work done by the charge? What,
Work done by the charge.
right? But delta G is work done on the charge. That's why we are changing the sign into negative sign.
No, but like when we, even in calorimetry, if we are talking about heat transfer, that we're talking in terms of the vessel. Heat is acting on the vessel, but we don't write heat lost by calorimeter is equal to heat gain minus of heat gained by calorie. We just put an equal to sign to equate the two. So here also, if we're talking about loss, there also there's loss and gain of heat energy, right? So here, in the same way, here we're again talking about loss on in terms of Gibbs free energy, but gain of electrical work. So why do we need a negative sign?
Because delta G is electrical work done by the cells, but W equal to NFE is giving you work done by the charge. So if you want to consider it as, work done on the charge, then the sign will be changed because then your point of reference, your frame of reference is the cell, which is actually doing the work.
But why do you want to?
Because physically, like if you are equating something, you need to be in the same frame of reference.
Oh, okay. Yeah, makes sense.
Ma'am, sorry to interrupt.
Ma'am, can I watch the recording of the last hour? I'm not feeling well.
Yeah, sure. Yeah, rest up, Smara.
Thank you, ma'am.
Okay. So variations of this thing at 298 Kelvin, like basically standard conditions, STP. Delta G becomes delta G naught because standard conditions will be equal to minus NF E naught of the cell. And we just saw what is E naught equal to. You can also write it as minus 2.303 RT by NF, or I'll just like continue this in the next page. It's gonna take some working. Yeah. Let me know till like if once you've completed here, then we'll look at the next relation.
So delta G is the work done on the charge, and what is by the charge? NFE.
Yeah.
Ma'am, I'll just rejoin.
Okay. Yeah, Arya, what's up?
Sia said.
Yeah, so delta G is work done by the cells, right? So that is on the charge.
Yeah, by the cells on the charge.
And NFE is work done by the charge on the cell.
Yes. On the cell, like it's work done by the charge. Yeah, you can say on the cell. Because transfer of electrons is causing the cell reaction. We have conductance. Cool. This done. Kaveri, you finished writing or just writing?
V would be E cell or E naught cell?
E cell at standard conditions वो E naught हो जाएगा.
Standard मतलब STP.
298 Kelvin, yeah, 1 atmosphere. Yeah.
What is R? Reaction.
हाँ, delta G, delta, like it's just representation.
Done.
Okay. All right. Next condition we're looking at is at equilibrium. So once the reaction reaches equilibrium, delta G naught equal to NF. What was the formula for E naught of the cell at equilibrium?
RT by NF into ln KC.
RT by NF into ln KC, right? So NF gets cancelled. So delta G naught will be equal to minus ln, if you want to convert it into log, 2.303 RT log KC. Is this ringing any bells?
Yeah, we just derived it.
So grade 11, when you're talking about this, you must have studied about Kc, and they just gave you, okay, this is the relation between Gibbs energy and like equilibrium constant. Now, this is the derivation of how that relation came to be. The whole story behind it. Right. All done till here? We'll do a question before starting the next topic. Actually, continue the previous question only. Chromium cadmium wala question you guys had done, right? You calculated log Kc in that case. Calculate the delta G also. Finish off that question. Ye wala question. You already got log Kc. So find out the delta G naught.
What is the difference between delta G and delta G naught?
Delta G is like, that's just Gibbs energy. Delta G naught is specifically at standard conditions, 298 Kelvin, 1 atmosphere pressure. So delta G can be calculated at any temperature, but when it is 298 given its standard condition, you denote it as delta G.
Unit is what?
Gibbs free energy है. Energy का
Joules per mole, right?
हाँ,
Joules per mole.
joules or kilojoules नहीं, joules ही होगा, because R is joules. Yeah, R is joules and then per mole and Kelvin. Yeah, joules per mole.
Oh, that's why they've given F, because
You don't need F either way because standard. I mean, NF cancel हो रहा है ना formula में.
oh yeah.
You need F if you're using NF E naught.
But we can like multiply 0.059 and F to get the
What?
like
Oh, to get the RT, yeah. Yeah. Oh, Arya is already Then, okay, I need to check the answer. Question 28. Okay, see, where is delta G? Oh, yes, you got it. Yeah. Whenever you have like really big values like these, you can also represent it in terms of, what do you call it?
I forgot what I got as log KC because it's in rough. What is it?
That's why always do problems like properly when you're practicing.
What is log K?
Calculate it again. Let this be a lesson. Do it the way you do it in fair. Like that way you'll get an idea kitna time le raha hai, and you'll also, have a practice of presenting your answer properly. Always do that.
I'm getting something very long.
Yeah, it'll be a large value. If you want, you can express it in kilojoules per mole, or you can send it in joules itself.
Even kilojoules will be in hundreds. Is that correct?
Yeah.
Can I round it off or?
Just send it, no? Like if you're already getting a big value, actually you're going to just calculate the first 3 digits and then round it off. No, like do the whole calculation. Don't cut corners. Even when you're rounding, just try to find at least like 2 decimal places. Yeah, see what's happening. Now I'm sending it. Oh no.
In joules, not kilojoules.
Nay, the number is very far off. Can you tell me the numbers what you've like used for calculation? Actually, one second. Uh,
Minus NFE, you will get state multiplication.
Huh?
See, yeah, the minus will not. I mean,
Yeah.
2.30.
Why do you need? Why do
2.30.
you? No, you can use NFE, so you get 6 into 96500 into 0.34. Done straight away. That you get.
yeah.
What?
Delta G is equal to NFE. You just do 6 into 9.
I use the other.
Now, what did you say
Why-
about the
why is-
minus?
Sia, can you repeat your question? You stuck. Actually, video is also frozen.
What did it, oh, what did you say about the minus?
Minus nothing, like that's fine. You got the number. And a phi naught. Yeah, minus will be there. Minus of a phi naught. Can't keep forgetting this.
Is it correct now?
Yeah. But alternate method, like if you use log KC, the math should add up, no? You can't get two different.
Maybe I made a calculation mistake. I'll check again.
Okay. Okay. Cool. Yeah, that's the kind of questions you'll get based on delta E. You get combinations. Sometimes you may be required to use Nernst equation to find E naught. And then using that, you find E naught or E, and then you use that to find delta G or KC, all that. That's right. Okay. The next part, some familiar concepts and some unfamiliar concepts. So the first thing being resistance. What is resistance?
How resistant it is to current flowing through.
Rho L by.
Awesome. So resistance is the hindrance provided, obstacle provided by, obstacle is not the right, but yeah, resisting the current flow.
Yeah.
The current flow. Yeah. So R is equal to rho L by A. What do each of these represent? Rho is
Rho is resistivity, L is the length of the wire, and A is the area of cross section.
length of the wire and A equal to area of the cross section. So resistance usually depends, resistivity, it's dependent on the nature of the material and temperature, but nature of temperature, nature of the material. Yeah, the length of wire when we're talking about like metallic this thing and area of the cross section. Even otherwise, like the length is like how long the current has to flow and the area that it has to like flow through. Right? What else do we have? Resistance. Okay. Unit of resistance.
Rho.
Huh?
Yeah, just say rho. I'm sorry, ohm.
Ohm. And unit of resistivity.
Ohm meter.
Here.
Ohm meter. Okay. So these are the SI unit. Let's keep that clear. Okay. Do you guys, can you define resistivity formally? Like if you were asked the definition of resistivity, you know how to express that?
Rho A by L.
Huh?
R A. What is happening?
Resistance.
R A by S.
Yeah, you just need to put that into words. Yeah. Yeah, I think Sia was saying.
Resistance offered by a material of area 1 meters, cross sectional area 1 meter square and length 1 meter.
Yeah, that's it. Okay. Now, new concepts. What would be the inverse of resistance? If resistance is,
Conductance.
Conductance.
yes. Conductance is how well a particular material can conduct electricity through it. The ease with which current flows through a conductor. Conductance is denoted by G. G is equal to, it's the inverse of resistance, so it is 1 by R, which means that will be equal to, you can write this as A upon rho L. Same things. This, you can write it, or 1 by rho into A upon L. A and L are like basically physical characteristics of the conductor. So this 1 by rho is called conductivity.
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 So 1 by rho represented by, it looks like K, it's a Greek alphabet for K, kappa into A by L. So here K is the conductivity. It's the counterpart of resistivity, like opposite of resistivity. Also called specific conductance. You can think of it this way. So the way you define resistivity, like conductance is kappa into A by L, Ka by L. So you can define conductivity as like conductance of a specific nature, like of length 1 meter and cross section 1 meter square. Here. So K,
If resistivity and conductivity are defined, I mean, obviously by putting one unit values in all of the substituting the unit value, then how is it dependent on the nature of the material? Anyway, kuch bhi hoga to then 1 ohm, 1 meter, and 1 meter square. So how
it
does it?
will not be 1 ohm. This will change. You're taking a nature, like you're taking a material and changing the things that you can control, which is having 1 meter square cross section and 1 meter of length, and then seeing, okay, what is the resistance offered by this, or how much.
So again, that will depend on the nature of the material.
Yes. Okay. So this, you can think of it as inverse of resistivity. So this is defined as conductance of a conductor or a solution. Like when you're applying it to an electrolyte, तभी solution हो जाएगा. If you're applying it to a metallic wire, it'll be a conductor of length 1 meter and area of cross section 1 meter square. Okay. So now, similar to this, we'll also look at the SI unit of conductance and conductivity. Finish? Huh? Okay. So SI unit of conductivity, start with conductance.
Mo or Simon.
Mo. It's reverse of ohm, इसलिए mo.
Or Simon.
Or yeah, denoted by S, shortened to S. Short form you will find S, or mu as like -1, because that 1 by R. And SI unit of conductance will be
Conductivity, no, not
conductivity, sorry, yes. Abhi conductance discussed here, this will be conductivity.